But I want to move on to the next one. So here's a couple students testing conductivity. So conductivity, if turbidity is stuff that you can see in the water, conductivity is going to be measuring stuff that you can't see in the water. What it is, so I'll leave this definition up here for a second. Water is a measure of how well water can conduct an electrical current. We're talking very, very small electrical current here. This little tool right here, this is the wireless conductivity probe. It has a little gap right there in the probe. And so when I put that in water, it gives a minor little electrical pulse, not enough to shock you or anything like that. It's just a very small pulse that happens right in there. And that pulse, it measures how well the water conducts electricity between these 2 points in that gate in the probe. So the reason we're measuring that is because what it's looking for is stuff that we don't see in the water. We can see stuff with turbidity. When things are bad with turbidity, we can see it. But if there's stuff like metals, heavy metals, that could potentially be harmful, if there's pesticides or other chemicals like that that we can't see, conductivity is going to be the thing that catches those. We don't test for every single possible thing that could be in the creek. They would just be too expensive, and we could run 50 tests and spend the entire year learning about watersheds, but I think we'd all be pretty tired of it. So we do this test to test for a whole variety of things, and that's what makes it important. This is what we call a watchdog test. It doesn't tell you exactly what the problem is. Right? There could be a high conductivity reading in the water, and it could be from a pesticide that's going in there. Or it could be from a metal. It could be from somebody draining their swimming pool in there, because the swimming pool water getting into the creek, the chlorine in there would cause a high conductivity. It doesn't really tell us what's causing it. It's just a watchdog. It tells us that something is going on, that there's something off in the creek. You really have to know what the baseline level is, because each creek is a little bit different, each river is a little bit different, but because we've been doing this for years, we have a pretty good baseline idea of what the conductivity should be in the creek. Usually it's somewhere in the range of like 80 to 120, depending on the site. And so the conductivity, that's, if you know the background conductivity, then you can see when a change happens. So why does this matter? Well, the stuff, the ions that are getting measured by it, those, a lot of the time, can be harmful. They aren't always. Some of the things that cause rises in conductivity are not necessarily bad things. It could be some nutrient that's in the water, that might make it higher. But some of these things, like stuff that might be found in a pesticide, that could have some ions that could raise the conductivity, and that would be bad. So it's not always harmful, but if conductivity goes up, that's something that we should be concerned about. The other issue too, this can also affect the pH, depending on what the ions are that are in there. This can be something that affects the pH of the stream as well. So this is sort of why this test matters. You're not going to be able to see the conductivity of a stream by looking at it. There might be some toxic chemical in the stream that's really bad for the things living in it, or bad for someone that's swimming in it or drinking from it. You wouldn't be able to see it at all, but the conductivity probe might be able to tell us about that. All right, and then lastly, what are the things that influence conductivity? What makes it higher, what makes it lower? So around here, most of the conductivity that's in the water just comes from the surroundings. What is the soil like? What are the rocks around it like? Again, some places with a lot of limestone, that would have a higher conductivity because of the calcium that's dissolved in the water. In some places, the soils naturally have a lot of minerals in them. That's not necessarily a bad thing. It would just have a higher baseline level. Usually we don't compare one stream to another. You have to know the background level. And we know the background level for Springbrook is around 100. So the surrounding rocks are a big determining factor. Another thing, this is a waste treatment plant. Right, we have a waste treatment plant right down by Foothills. Even if the waste has been treated, the water that goes back into the creek, or back into the river, in this case into the Lemon, that water can have a higher conductivity. If it's untreated sewage, that untreated sewage can really raise the conductivity as well. Just industrial waste, things like that. If there's a pipe and waste from a factory, some sort of industry is going in, that's more than likely going to increase the conductivity. And then there's a lot of stuff related to agriculture. So pesticides that get sprayed on crops in order to try to kill the insects, that will almost certainly increase conductivity. Fertilizers that people put on their lawns, that can increase conductivity. Herbicides that kill weeds, things like that, that can increase conductivity. So all of those are things that potentially could cause rises. Here in Lake Oswego, industrial waste, not a big issue. Human and animal waste, maybe a little bit. But some of these things like fertilizers, pesticides, and herbicides that people use on lawns, that potentially could be an issue. But the biggest one is just going to be the surrounding rocks, the surrounding soil. That's probably going to be the biggest influencer on conductivity. All right, so in terms of things, you don't need to write any of this down. In terms of some of the things that actually do the increasing in the water, it can be a huge range of things. I sort of mentioned this before. Some of the things like phosphorus and nitrogen, those aren't toxic. Some of the things like mercury, if there's chlorine that was in the water, those would be things that would be toxic. So some of the things are toxic, some are not. Both might raise conductivity. Conductivity can have a huge range. This is one of those things where if I do the conductivity, you probably won't be able to see this here, but if I take the conductivity probe and put it in the tap water, the number isn't huge. It comes out to about 118 is the number that it's reading on there. So tap water doesn't have a super high conductivity. But if you get salty water, like if I add in salt into the water here and sort of stir that around, now because it has salt in it, it's probably going to have a little bit higher conductivity. So I read that, and yeah, it's not only a little higher, it's now up to over 10,000 just by adding that salt in there. The salt ions, the sodium and chloride in there, made it raise up quite a bit. It would be the same thing if you did like a camp soda, if you looked at Gatorade, something like that. If you put the conductivity probe in those things, it's going to read, Gatorade is an especially good example because it has those electrolytes dissolved in it, it's going to be pretty high. So salt water can be really high in conductivity. If you want sort of an extreme example, I took some of the water from our waste bucket in back, the yellow bucket in the back of the classroom. This has all the remains from like the dissolved oxygen and the alkalinity test, and I wanted to see what the conductivity of that was. If I stick the probe in there, the reading that it comes out to, the reading on this is 42,000. Okay, so it's really high because that's where we dumped all those chemicals in there. So 42,000, that's a lot higher than the 120 that was in the tap water. So there's a big range. You guys are going to be testing the conductivity of, so data sheet on page 47, you're going to be testing the conductivity of that Tryon Creek water, the same water we use for the macroinvertebrates. So you're going to get a reading in each of those buckets using this probe. It's pretty easy to use. You have to wirelessly set up your probe with the LabQuest. The directions for that are in your lab manual on page 45, I believe. So the directions for pairing these two things is on there. And then you'll go ahead and do these. These two labs today are extremely easy labs. You should be able to complete them both probably in 15 minutes, so it's not going to take you a real long time. One group, or one lab sheet per group. I'm going to let you guys pick your lab groups today. If you want to test the conductivity of anything else, if you want to test any of the other aquariums in the classroom, if you want to test the waste bucket or tap water, or even a sports drink or something like that, you can use these to test the conductivity of those things as well. But as far as what you need to do, you just need to get readings from both of the Tryon Creek buckets with the conductivity probe, and then you need to get a couple turbidity readings as well. So that's really all that I've got for today. Hopefully you were able to see this and everything sort of was clear and understandable. I'll be back next class on Monday, and we'll be learning about our last string parameter and start getting ready for our final visit out to Springbrook Creek to do our official water quality testing. So that's just a couple classes away as well. But for today, turbidity, conductivity, 2 important parameters in the stream. Homework this evening is reading about sediments in the stream and about turbidity. And that's all for today. Have a great rest of your day, and I will see you guys next week. Thanks.